All right, welcome back. So today we're going to talk about ionic bonds, ions, ionic bonds, and all those wonderful things. So the first thing we're going to be doing is going to be working on some of the properties of ionic bonds. So ionic bonds, ionic bonds. Sounds like a bad spy novel. I'm Ionic Bonds. Anyway, alright, alright. So let's go with a different color. Let's go with black. There we are. Okay, so, first of all, they conduct electricity. And that's because of the transfer of the electrons from the metal to the non-metal. Conduct electricity. If you stepped in pure water with 1,000 or 100 million volts of electricity in the water, and there was absolutely no ionic bonds in there, no salts of any sort, you wouldn't get electrocuted. I, however, would never attempt it because there's always going to be that little bit of tiny bit of doubt. And also, the salt you have is going to get drawn out of you into the water and you'll end up electrocuting yourself. So, yeah, that's bad. Anyway, so they form a salt. Form a salts. And that's many different salts. That could be magnesium sulfate, which is Epsom salts, which you soak your feet in. It can be table salt. It can be copper sulfate, which is used. It's a blue crystal that's used in killing tree stumps. Tree roots, and then in drain pipes, and then there's also the rocks, literally, that are in your gypsum boards, as well as or salts that are in your gypsum boards and the boards that you make up in your walls in new homes today. That's a salt. That's a type of salt. So we also can look at so they form crystals, and it can be different types of crystals, and they can be something like that. Or they can also be something that looks like that. And I'm a horrible drawer, but that's not bad. I mean, considering I'm a horrible drawer. Anyway, so they can form different types of crystals because of the way that the electron or the atoms bond together. They will form a metal. I'm sorry, they always form with a metal plus a non-metal. If you look at the ionic charge, which is below the words, the periodic table, you have +1 above the first group, +2 above the second group, +3 above the third group, plus -1 above the fluorine group, the 17th group, -2 is above the oxygen group, the 16th group, and -3 above the 15th group. And then I misstated. It's +3 is above the 13th group boron. So any of these elements for group 1 is going to have a +1 charge for hydrogen, a +1 charge for lithium, a +1 charge for sodium, a +1 charge for potassium, rubidium, cesium, and francium. For this -1, we'll have above the 17th group, it'll be -1 for fluorine, -1 for chlorine, -1 for bromine, iodine, astatine, and tennessinium. So now let's go back to our regularly scheduled thing. So if we were to take, let's say, Na, if we go back to our periodic table, Na is in the first group right here. And so that would be a +1. And then fluorine would be a -1 here. Right here is fluorine. And going back to our other one, so that also is going to be a -1. So the assignment today was that you were supposed to look at the different elements. Let's take a different one. Let's do calcium. Calcium would be Ca. Ca is right here in this corner. Element 21. I'm sorry, 20. So then we would have Ca. And going back to our periodic table, Ca is right here. And so that would be group 2, so it would have a +2 charge. A +2 charge. Okay, so now that leaves us with, let's go calcium, let's go with calcium chloride. It's one of the different types of salts that you put on ice so you don't slip. So calcium chloride, it is in group 17, so it's going to have a -1 charge. And so calcium chloride would be a -1 charge. Now, you're like, oh, okay, that's easy and whatever. Yes. However, now we're going to go into what you guys are going to be doing for the next lesson. The way that these form is you take the superscript without the positive or the negative, and you crisscross them. This is to make the elemental or the compound formulas. So in this case, they're both 1, so it'd be Na1, F1, which if they're both the same numbers of subscripts, we just ignore those. So then it'd be N, A, and F. Now here we have calcium would be 2 and chlorine would be 1. So we move these down as subscripts. So then we would have Ca, the 1 comes from the chlorine, and then the Cl, the 2 comes from the calcium. We crisscross. We basically swap numbers as superscripts and move them down into subscripts. What that means is that for every 1 piece of sodium here, I need 1 piece of fluorine to make sodium fluoride, which we'll get into naming in a bit. Not today, though. So, for calcium, for the other one, we have calcium. We have 1 piece of calcium needed here to combine with 2 pieces of chlorine to give us calcium. We don't write the 1s as subscripts. If you do that in my class, I'm not going to mark you wrong. But in other people's classes, other teachers' classes for chemistry, they may mark you wrong. But I won't do it. But so you have one piece of calcium combining with two pieces of chlorine. And so this would be the way to properly write calcium chloride. And that's where we're going to leave off. If you have any issues or problems, please text message me or email me. If for the students in my class, for those people who aren't in my class but have questions, please feel free to leave a comment below, and I will respond within a day or so. Anyway, peace out. You have a wonderful day, and talk to you later. Bye.